So today we're going to be going over section 3.1. We're going to spend a couple days on this section. Today is day 1. And we're going to be learning about something called the derivative of a function. When we want to find the instantaneous rate of change for a function at a specific point, we call this value the derivative of the function. If you think back to the activity we did on the very first day of chapter 2, we said instantaneous rate of change is kind of like pointing a radar gun and saying, how fast am I going right now? A derivative will help us get that speed. So it's essentially allowing us to find the slope of a line at one point, where normally we need 2 points. To calculate the value of a derivative, this is the formula that we use. We find the limit as x approaches a of f of x minus f of a all over x minus a. So to calculate a derivative, we're going to need to remember everything that we learned about calculating a limit. Now, if you think about a normal slope formula, normally slope would be y2 minus y1 over x2 minus x1. This is slope. Basically, this formula is the limit version of slope. F of x is y2, f of a is y1. X is x2, a is x1. So we're just taking the limit of our regular old slope formula. Let me show you some examples. It says calculate the value of the derivative of the following functions at the given value. And it tells me specifically what x value to use. So in this problem, a would equal 2. Now our limit would be the limit as x approaches a of f of x minus f of a all over x minus a. When we apply this formula to this specific problem, we would have the limit as x approaches 2. Let me make this a different color. 2, because in this problem, a is 2. Then we would have f of x. Now you'll notice that it says here that f of x is 1 over x. So I'm going to put 1 over x here. Minus, now we have f of a. F of a would mean take the number 2 and plug it in here. So we would have 1 over 2 all over x, which is just x, minus a, which we said was 2. Now we're going to simplify. First, we know that the number one rule for limits is if you can find the limit, you can just plug it in, then you just do it. You just plug it in. So if I plug in the number 2 here, though, you'll notice we get 2 minus 2 in the denominator, which is 0, so that's bad. So what you're going to find is that in most of these questions, you're going to need to algebra to get the limit to work. In this problem, what I'm going to do is I'm going to multiply the whole thing by the common denominator. Now the invisible denominator on the bottom is a 1. So if I look at all 3 of these denominators, I'm doing the common denominator. If I look at all 3 of these denominators, I get 2x. So I'm going to multiply each fraction separately by 2x and see what happens. My new limit is going to be the limit as x approaches 2 of, in the first fraction the x's cancel, so it's just a 2, minus in the second fraction the 2's cancels, so it's an x. All over, nothing cancels on the bottom, so it would be 2x times x minus 2. Now I'm so close to getting what I want, which is for this x minus 2 to cancel. The only difference here is that 2 minus x and x minus 2 are not exactly the same. So one note that I would make is that if we factor out a negative 1, then 2 minus x becomes negative 1 parentheses x minus 2. Because of that, my new limit would be the limit as x approaches 2 of negative 1 parentheses x minus 2 over 2x parentheses x minus 2. So the x minus 2 and the x minus 2 would cancel, which means I would have the limit as x approaches 2 of negative 1 over 2x. At this point, I can actually plug in my number 2, so I would get negative 1/4. All right, let's go through the steps. Here's the general formula. I'm going to just substitute. A becomes 2. F of x is just the original function. F of a is the original function with this number plugged in. X minus a is 2. Algebra some stuff, which we practiced in the last chapter. Plug in your number and you're done. Let's go over problem 2. Our general formula would be the limit as x approaches a of f of x minus f of a all over x minus a. Now in this problem, a is going to be equal to 1. It says that in the directions. So let's fill in and substitute the values we know. We're going to have the limit as x approaches 1, because a is 1, of f of x. F of x in this problem is x squared plus 4, minus f of a would just be this same function, but with the number 1 plugged in, so 1 squared plus 4, all over x minus a in this problem is a 1. Now we're going to simplify. So if I simplify this, I get the limit as x approaches 1 of x squared plus 4. 1 squared plus 4, 1 squared is 1 plus 4 is 5, so it's just minus 5 all over x minus 1. Now in this problem, instead of a common denominator, I'm going to simplify this a little bit more, and I'm going to have the limit as x approaches 1 of x squared minus 1 over x minus 1. I'm just going to, instead of common denominator, I'm going to do factoring as my algebra technique. So the numerator is going to factor to be x plus 1 times x minus 1, and then we're going to have the limit as x approaches 1 of x plus 1 times x minus 1 all over x minus 1. The x minus 1's cancel, and so we just get the limit as x approaches 1 of x plus 1. Now we can substitute, so if you can plug it in, you just plug it in and you get 2. Now what does this really mean? This really means that the slope of 1 over x at exactly x equals 2 is negative 1/4. And this here really means that the slope of x squared plus 4 at exactly x equals 1 is 2. So if I want to find the slope at a single point, I just did it. All right, now on the next page, how can we find a general formula? So sometimes, instead of wanting to know the slope at a specific point, we want to get what's called a derivative function. When we want to find a general formula that would allow us to calculate a bunch of instantaneous rates of change, it seems silly to just sort of do this long process for each new number we wanted to check. So what we're going to do is we're going to find what's called a general derivative. The formula for a general derivative is the limit as h approaches 0 of f of x plus h minus f of x all over h. You may remember this part of the formula from pre-calculus. It was called the difference quotient. We're basically just doing the difference quotient and taking the limit of the answer. When we find this general formula, we say that we found the derivative of the function. And what that allows us to do is answer questions like this one. It says differentiate. Differentiate is another word for take the derivative of. The function f of x equals x cubed. Then use the derivative to find the instantaneous rate of change at 2, 3, and 4. Now our other formula would allow us to find those things, but we would need to do that formula 3 separate times. We would need to do this process at 2, at 3, and at 4. If we find this general formula, then when we get to the end, we can get all 3 of these answers and only do the problem one time. So this particular method is really good for if you want to find a general function. The other method is really good for if you want to find a specific number. All right, so to find this limit, we know we need to use the formula, the limit as h approaches 0 of f of x plus h minus f of x all over h. Now here's where it gets a little bit tricky. So some students have some trouble with this. I would encourage you to think about the top as being two different problems, f of x plus h and f of x. If I want to find f of x plus h, that means go back to the original formula. Anywhere you see an x, put an x plus h instead. So instead of x cubed, it's going to be x plus h cubed. Does that make sense? Then minus. Now f of x means go back to the original formula, and it's just the original function. So we're not changing it, it's just an x still. So we would have x cubed all over h. From here, it's just really algebraing until you can't algebra anymore. So bear with me through this process. I understand that it's kind of a pain sometimes, but it's not hard. So just go through it and you'll be fine. X plus h cubed really means x plus h times x plus h times x plus h minus x cubed over h. So the first thing we're going to do here is we're going to multiply these two together, and then we'll multiply the third one when we're done. When I FOIL, I get x squared plus x times h plus h times x, which is the same thing, plus h squared. And that whole thing still needs to be multiplied by x plus h minus x cubed all over h. So this part of my problem right here comes from multiplying these two pieces together. Now I'm going to simplify. So instead of x plus h and x plus h, I'm going to simplify that to 2x plus h. Sorry, 2xh. Now I'm going to FOIL the whole thing out one more time. So again, I'm just distributing. X squared times x would be x cubed. X squared times h would be plus x squared h. 2xh times x would be plus 2x squared h. 2xh times h would be 2xh squared. H squared times x would be xh squared. H squared times h would be h cubed. Don't forget about the minus x cubed all over h. Now there are definitely some common terms here, like terms. The first thing I notice if I'm algebraing is that x cubed and x cubed cancel. Woohoo! Now I see some like terms. So x squared h, 2x squared h would be 3x squared h. 2xh squared plus 1xh squared would be 3xh squared. And then I'm just going to copy down the h cubed. all over h. I still can't plug in 0 because the h is still in the bottom, but if I factor out an h from the numerator, I have 3x squared plus 3xh plus h squared. Then this h and this h cancel. So now I can plug in 0. So my limit as h approaches 0 of 3x squared plus 3xh plus h squared. If h is 0, then this term and this term cancel because those become zeros. So my answer here would just be 3x squared. This right here is called the derivative. Now if I want to find the derivative at x equals 2, which it told me to do in the instructions, I just take the number 2 and I plug it in here. So 3 times 2 squared would be 12. If I want to find the derivative at x equals 3, I would have 3 times 3 squared, which is 27. And if I want to find the derivative at x equals 4, I would have 3 times 4 squared, which would be 32. These are all the slopes of x cubed at specific x values. Now, this notation, it works for us for right now, but technically there's a much better notation. So the next page, we're not really doing anything crazy. We're just looking at some notation. The first notation is what's called prime notation. If you read this, you say y prime. And really what it means is just take the derivative of this function. It means take the derivative. dy dx, you would literally say dy dx. And again, this just means derivative. And if you see it like this, you would literally just say d dx of f of x. Now here's how we can use derivatives. We learned previously that the tangent line requires us to have the slope at a single point. To find the equation of the tangent line to this graph at this specific point, we need two things. We need a point and we need a slope. The point is going to have this x value. So this x is the x that goes here. Now to calculate the y, we just plug it in here. So 1 squared would be 1, would be a point on the graph of the original function. To figure out the slope, we need to do the limit as x approaches a of f of x minus f of a all over x minus a. Now the reason I'm using that formula instead of the general formula that we just went over is because it's faster, it's simpler, and I have a specific number. So, because my specific number is a 1, I want the limit as x approaches 1 of f of x, which is just x squared, minus f of 1, which means plug 1 in, you get 1, all over x minus plug in the 1, you get 1. Now if I simplify that, I think factoring is the obvious algebraic choice. So x plus 1 times x minus 1 divided by x minus 1. The x minus 1's cancel. So the limit as x approaches 1 of just x plus 1, if I plug that in, I get 2. Which means my tangent line equation would be y minus 1 equals 2 times x minus 1. Again, I always just use point slope form. I'm never going to, do anything crazy. Just want point slope form. All right, find the equation for the tangent line to this curve at this point on this curve. So again, to find the equation of a tangent line, I need two things. I need a point and I need a slope. The point was given to me. To find the slope, I'm going to use the limit as x approaches a of f of x minus f of a all over x minus a. In this case, a would just be 2 because that's the x value. Limit as x approaches 2, f of x would just be 2 over x minus f of a. If I plug in 2, I get 1. That's my y value. All over x minus 2. I think the obvious choice here again is common denominators. So this denominator would be a 1. This denominator would be a 1. The common denominator would be an x. If I distribute that, I get the limit as x approaches 2. The x would cancel, so I would get 2 minus, nothing cancels, so x, all over, nothing cancels, so x parentheses x minus 2. Again, we're so close to being able to cancel. We're so close, but in order to make it work, we need to factor out a negative 1. So limit as x approaches 2 of negative 1 times x minus 2 over x times x minus 2. The x minus 2's cancel, so I get the limit as x approaches 2 of negative 1 over x. If I plug in the 2, I get negative 1/2. That's my slope, which means my tangent line would be y minus 1 equals negative 1/2 times x minus 2. And we're good. All right, I'll see you guys in class tomorrow.